Welcome back to Alfie Revises Physics. It's time for the Newton's third and I hope final law with CP2e. So let's dive right in with the definition. It's all about how how the forces on two different objects when they interact. So forces, object interactions. Objects interacting forces, how about that? Yes. Objects interacting forces is how we'll define Newton's third law. Okay. Okay, let's look at this. Let's just have a little read. It's a pair of forces acting on two interactive objects, often called an action-reaction force. The two forces are always the same size and in opposite directions. They're also the same type of force. In photo A, the rope and the dog are both exerting pulling forces on each other. In photo B, the two forces are both gravitational forces. So these are both kinetic forces, and the dog is staying still because it's pulling the same amount as the rope. Okay. Think about the vertical forces in photo A. One force is the weight of the dog pushing down on the ground. What's the other force in this pair? The ground pushing up on the dog. The weight of dog pushing down on the ground. The ground pushing up on the dog is the other force. I know it sounds ridiculous, but force from ground on dog is the other option here. So you've got that, and next up is over here. Let's go. Okay, action-reaction forces. So that's what I think this should be. But okay. So action-reaction forces are the really stupidly worded. No, not stupidly, but simply worded versions of balance forces. Force from ground on dog, force from dog on ground, force from dog on rope, force from rope on dog. So they're just the exact same thing but opposite. Whereas balance forces are the same things but with actual names. So force of gravity on dog instead of force on dog on ground. Force from ground on dog is the same because there's no real name for that. Force from rope on dog, force of friction on dog. There you are. It's like that but named. Collisions. We can apply the idea of action-reaction forces to what happens when things collide. The action-reaction forces that occur in the collision are the same size, but do not necessarily have the same effects on the two objects, because the objects will have different masses. Okay. Describe the action-reaction forces when the ball bounces on the ground. Action-reaction is all this simple stuff, so ground pushes up on the ball, ball pushes down on the ground, I suppose so. Look at photo D. The player's head and the ball both change velocity during the collision. Describe the effects on the two objects and explain why their effects are different. The ball weighs a lot less and is less dense than the player's head. So the ball will bounce back, but the player's head will bounce back a little bit, but the ball will probably bounce off because it's less dense and lighter. We should probably have a go at another question because this is rather confusing. For the situation in question 2, which is, okay, you're standing leaning on a wall. Draw a sketch to show this. So, like this. So you're leaning on a wall. Add arrows to show an action-reaction pair of forces. I will add a wall here. So it's a cross-section. There's a wall there. Okay. Action-reaction from pair of forces, including the vertical direction and horizontal direction. So, human on ground, ground on human, human on wall, wall on human. For the situation in question 2, describe the balance forces on you acting in the vertical direction. So the more detailed version of ground on floor, floor on human. Sorry, human on floor, floor on human. So that would be gravity and force from ground on person. So that would be the answer to them. I think we do need to, yeah, alright. Let's just have a look at this, see if we need to do any more research. A student is using a force meter to find the weight of an apple. Describe the pair of action-reaction pair of forces in this situation. So, I believe the force meter is something like this that I've used before. It's got a little ring here and a digital display here. And then you've got the apple here. Very good apple. So you've got the weight of the apple pulling down. I think, is it balanced or okay, action reaction. So apple pulling down, I'll label that. Or our action reaction force is always a push, so it would be, no, it wouldn't, that would not make sense. So we'll leave it at apple pulling down, and then we can draw another arrow going up, which says, text, which says force meter pulling up. Multiple spelling mistakes there, but all typos. Force meter pulling up, apple meter pulling down. That's one mark, so that's literally all we need to do. So ignore the diagram. Diagram was just for show, but these two lines here are all you need to get that one mark. So there's your one mark. Newton's third law was rather short as a topic, and it's just because I didn't write much really. But ultimately, this is all you need to know, the basics on CP2e Newton's third law. See ya and goodbye.